Hi students, this video is about a prerequisite of video number 2 that we have posted. I want you to listen well to that video. Equation of tangent to f of x at the point A f of A, and the point A must belong to f of x, is y minus ya equal derivative at the point A into x minus x of A. This is the equation of a line that you took in intermediate 2 or 3, where y minus ya equals slope into x minus x of A. However, equation of the tangent, because the slope is the derivative, so we put the derivative. What I'm talking about here, if you have a curve, and you want to find, and you have a point A on the curve, and you want to find the equation of tangent, so it's a line, and this equation of tangent has for equation y minus ya equal y prime of A into x minus x of A. So how do we, let us take some example. Find the equation of tangent to f of x equal 2x squared minus x plus 2 at the point A whose abscissa is 2. So since I want the equation of tangent, first of all I write the equation of tangent, y minus ya equal y prime of A into x minus x of A. The unknowns here are y of A, y prime of A, and x of A. X of A is given first of all, which is 2. I need to find y of A. So I replace here in the x, f of x, x by 2. You're going to get 8 minus 2 plus 2, so 8. I need y prime of the point 2, so I do the derivative for x minus 1. So I replace by 2 because I want at the abscissa 2. 8 minus 1, 7. So now the equation will be y minus y of A, it means y of A is 8, equals slope derivative 7 into x minus x of A, which is 2. So the equation will be 7x minus 6. To graph, we take any two particular points. You can take x is 0 and get minus 6, or x is 1 and get 1. Okay, so let us do it here. We have equation at the point at 2x squared minus x plus 2. Y equal to x squared 2x squared minus x plus 2, and you want tangent. You have a point A with component 2 f of 2, you have 2 8, let us see it here, and you want to find the equation, sorry, tangent point A to curve f. Sorry, because I have put it capital, I cannot put it capital, let me delete it all. So tangent point A small f. So this is the equation of tangent by taking particular points. Okay, so let us continue. More example. Find the equation of tangent to f of x at the point of abscissa 0. Similarly, you will need to find first of all f of 0. You replace here by 0, which is minus 1. You do the derivative u over v, u prime 2 into v 3x plus 1 minus derivative of 3x plus 1, 3 into 2x minus 1 over denominator square. If you expand, you're going to get this one. 6 minus 6x cancel out. 2 plus 3 is 5. I want f prime of 0 because I want the derivative at the point 0. So you're going to get 5. So you say y minus y of A, y plus 1 equal y prime is 5 into x minus 0, which is 5x minus 1. And if you want to graph, you take two particular points. For example, here, you can say if x is 0, y minus 1, if x is 1, it will be 4, and you graph the line. This is a line, nothing else than a line. Center of symmetry. A point is a center of symmetry for any function if f of 2a minus x plus f of x equal to b, where a is the abscissa of the point and b is the ordinate of the point. So what do we mean by this one? Here you have 3, 2. Let us go to GeoGebra to tell you before what does it mean. Suppose you have f of x equal to x minus 1 divided, sorry, to x minus 1 divided by x minus 3, and if you pick the point, which is here, let me put it, the point 3, 2. Okay, let me delete this one. So here, if you can see, if you pick, this is the center of symmetry of the curve. Why? Because if you pick any point here and you want to do the reflection above the point B to A, and if you join the segment, okay, and if you do some animation here, as you can see, this is center of symmetry, as you can see. Okay, let me do it, repeat it. So this is center of symmetry. So I want to show that this point is a center of symmetry of this curve. Okay, so this is point B. Let me stop the animation. Okay, so here you need to show that this point is a center of symmetry as I showed you before. So here the formula say to prove that a point is a center of symmetry, you need to show that A here is a 3, A is a 3, B is 2, so we need to show that f of 2a minus x, since a is a 3, f of 6 minus x plus f of x equal to b, which is 4. So I'm going to start by f of 6 minus x. So you go to f of x. For these two x's, you replace 6 minus x. So 2 parentheses 6 minus x minus 1 over 6 minus x minus 3 plus f of x as it is. So if you expand the 12 minus 1, 11 minus 2x over minus x plus 3 over plus the other one. Now I want to tell you here, always, 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 you're going to get opposite. So to be the same, you multiply up by minus 1 and down by minus 1. If you multiply down by minus 1, you're going to get x minus 3 and up minus 11 plus 2x. So here you have same denominator, you just add the numerator. So for x minus 12, you can put 4 in factor. X minus 3 over x minus 3, you can cancel both. So it's equal to 4, what I want to show. So we show that we have a center of symmetry. Another example, show that the point minus 2, 2 is a center of symmetry of this one. So what we need to show that f of 2a minus x plus f of x equal to b, where a is minus 2 and b is 2. So I want to show that f of minus 4 minus x plus f of x equal also to b. Here it's minus, sorry, it's equal minus 4. So I go to f of x here. I replace every x by minus 4 minus x here, here, and down, plus f of x. So this is a plus b squared because you can put the minus outside, and the square it will go. Sorry, it will go. So why it will disappear? Because I have a square. Let me tell you what I mean. If you can write it like this, minus x plus 4 square. So we don't have any more minus. So we're going to have, and it's the same as a plus b squared. So 16 plus 8x plus x squared minus 8 minus 2x plus 1 over minus x minus 2. So you multiply up by minus 1, down by minus 1. Always we have this strategy. 16 minus 8 is 8. 8 plus 1, 9. Because I multiplied by minus 1 as I did up here. so minus 9. X squared is minus x squared, 8x minus 2x minus 6x. So because you have same denominator, you just add the numerator, as you can see here. So 2x squared cancel, sorry, minus x squared plus x squared cancel out. You have minus 6x plus 2x minus 4x. And then here you can put minus 4 in factor. You're going to get x plus 2 over x plus 2. So it's minus 4 what I want to show. So this is concerning center of symmetry. Now I have we're going to talk about something else, which is called relative position of two functions. So relative position of two functions, f of x and g of x, what does it mean? Let me tell you, if you have two functions, one is f of x and one is g of x. So this is f of x, this is g of x, and if you have intersection which is a point A, relative position, so as you can see in this part, g of x is above, if A from A and down, then g of x is below the function if you have x and y axis. So that's what I'm going to discuss. When the first function is above the other, when it's below the other. So here it's above from A and down because elevation of that part is higher than this one. And if you go down, g of x elevation will be lower than the other one. So studying the relative position of two functions f of x and g of x is the same as studying the sign of f of x minus g of x. So anytime you have a question about relative position, you need to do the table of sign of f of x minus g of x. If f of x minus g of x bigger than 0 on this interval, it means f of x bigger than g of x. It means f of x above g of x. If it's less than 0, it means f of x below. If it's equal to 0, they cut. So let us do it here and understand it. Study the relative position of f of x with respect to its horizontal asymptote. What's horizontal asymptote? I gave you the horizontal asymptote. We do limit at infinity, so it's 2x over x. 2x over x, which is 2. Anyway, we're going to talk in this video about horizontal and vertical asymptote. So I gave you here. So you need to study the sign of f of x minus 2, f of x minus 2. So you write f of x minus 2, you do same denominator, you're going to get this one. Now, you know, we want to find table of sign. 5 here, I don't have x to find the root. I don't have x to find, so I have only 3 down. And this 3 is impossible. Why? Because it's in denominator. I do x, table of sign, f of x minus 2, minus infinity till infinity. I put the 3, and the 3 is impossible. Now I take a value before 3. Let us take 2. So negative, bigger than 3, for example 4, positive. So if x from minus infinity till 3, f of x minus 2 less than 0, it means f of x below g of x. If x belongs from 3 till infinity, it means f of x minus 2 positive. It means f of x is above g of x. So let us see it in GeoGebra. Let me write the function. You have function 2x minus 1 over x minus 3 with respect to y equal to 2. Let us go to GeoGebra. So here, so we have f of x 2x minus 1 over x minus 3. We have y equal to 2. What do you realize, guys? We realize, and you have x equal to 3 we found. So we realize that you have, this is y equal to 2, and this is the function f of x, and this is y equal to 2. So if x, as you can see here, if x smaller than 3, this curve is below the horizontal line. However, if x bigger than 3, this curve, which is f of x, is above the line. So if this is x equal to 3, if it's below, less from minus infinity till 3, the curve is below the horizontal asymptote. Bigger than 3, the curve is above. Okay, so that's what I meant here in this relative position that we had it here. Another example, study relative position of f of x with respect to its oblique asymptote. You took oblique asymptote last year, but I'm going to re-explain it in another video with respect to y equal to x. So I do minus each other. So same denominator, you have this one. Now, as we said before, I have only one root, which is minus 2. So you put it impossible. You take an answer, a number less than minus 2, minus 3, it will be negative. Bigger than minus 2, 0, positive. So if x between minus infinity till minus 2, f of x below y equal to x. Sorry, here you have y equal to x, because I do copy paste and sometimes I forget to change it. Okay, so here if x, sorry, this is correct, minus 2. So f of x below g of x, and if x belong from minus 2 till infinity, f of x minus x bigger than 0, so f of x above g of x equal to x. I'm going to tell you, suppose for example you're doing f of x minus gx, you're going to get, for example, x plus 2 over x minus 3. So here how many roots I have? I have 2 roots for table of sign. One is minus 2, the other one is a 3. 3 is impossible, but I write it as hashed line. So you have minus infinity. I'm studying the relative position, don't forget. Here, the 3 is impossible. Here, f of x, f minus g. So you take a number less than minus 2. Let me take minus 3. Here, negative, negative, positive. Between minus 2 and 3, 0. So negative. Bigger than 3, take 5. Positive if you replace. So if x belongs from minus infinity till minus 2 or 3, here you close it. Let me tell you what I want to write. From minus infinity open, sorry, till minus 2 open, union 3 till infinity. It's positive. It means f of x is above g, because f minus g is plus in f bigger than g. If x belongs from minus 2 till 3 open, all open, it means f of x below. If x equal minus 2, they intersect at that point. You can find the abscissa of the point by replacing minus 2 either in f or g. So if x equal minus 2, the two functions, they intersect. If x equal to 3, they don't intersect. You have a vertical asymptote. No need to mention anything about. Okay? Domain of definition, guys. Everything that makes denominator 0 is a vertical asymptote. Okay? Condition, it cannot be 0 over 0. It will not be a vertical asymptote. However, in all examples we're going to take, we're going to have values. If the denominator is 0, it will be a vertical asymptote. We must exclude that point. So if I want to find the domain of definition here, I say 3x plus 2 equal to 0, x equal minus 2 over 3. So I excluded, as you know. Here, x cannot be 0 nor 1. You must exclude. So how many vertical asymptote here I have? I have 2. X is equal to 0, a vertical asymptote. X equal to 1, a vertical asymptote. Here I do delta. Also I have 2 vertical asymptote. For horizontal asymptote, guys, I do what? Limit as x tends horizontal plus or minus infinity. Okay. So for the first one, highest power over highest power you do for horizontal asymptote. Here you have 2 over 3. For the second one, I'm finding the horizontal asymptote for the second one. You're going to get 2x highest power up, and highest power down is x squared. So 2 over x. A number over infinity is what? 0. So always when degree below, like here, and the problem in B and C in denominator bigger than numerator, if you have rational function, always you have y equal to 0. If degrees are equal, you have coefficient of over quotient. If degree up is bigger, for example, suppose you want to find the limit at infinity of this one. Here you have what's called oblique asymptote. Here you have, so if you do limit at infinity, I don't have a place to write limit at infinity. You're going to write x squared, highest over highest. You're going to get x over 2, and x over 2 is infinity if you do the limit. Here we have oblique asymptote. So that's why if you have ax over bx, if degree above equal degree below, you have y equal a over b. For example, suppose degree up is 2x squared minus 3x plus 1, and you want to find the horizontal asymptote over x squared plus 2. So if you want to do the limit at infinity, here, you're going to get 2x squared, always highest over highest limit at infinity. You took it last year. So here you're going to say y equal to 2 horizontal asymptote. You have y equal to 2 horizontal asymptote. And if you do the limit at another one, for example, this one also horizontal asymptote 2 over 3. This one, because degree below is bigger, directly is 0. If degree above is bigger, you have oblique asymptote. Let us talk about in details. Horizontal asymptote are limits at infinity, as I said now. Vertical asymptotes are for values that makes denominator equal to 0. Suppose a is not 0, don't forget that a over 0 is a plus or minus infinity. A number over infinity is also what, guys? 0. A number over infinity is 0. Find the asymptote, so let me write it. A number a not over infinity is 0. Okay, find the asymptote of, first of all, I do the domain of definition, which is the vertical asymptote. So x cannot be minus 2 over 3. Let me start by the horizontal asymptote. For the horizontal asymptote, why I do horizontal asymptote? Because here you have from minus infinity, minus 2 over 3, union, minus 2 over 3 till infinity. I need to know the behavior at infinite points, what's happening to the curve. So this is horizontal asymptote. So we do the limit at infinity, it will be 2x over 3x, 2 over 3. So y equal 2 over 3 horizontal asymptote. For vertical asymptote, value that make denominator is 0. So if you replace by minus 2 over 3 here, you're going to get a number over 0 plus or minus infinity. So x equal minus 2 over 3 vertical asymptote. So here we have one horizontal and one vertical. I want to talk about something. Guys, if you have a over 0 plus, or let me see this one before I talk about this. So here I want to find the domain of definition. X cannot be 0, x cannot be 1. You have here these two. So I have two vertical asymptotes. X is 0, x is 1. You need to show it. You do, first of all, let me do the limit at infinity. So 2x over x squared. So a number over infinity is 0. So because degree below is bigger, always y equal to 0 horizontal asymptote. Now I want to do the limit as x tends to 0. If you do the limit as x tends to 0, you have minus 1 over 0 plus or minus infinity. So we have x equal to 0 vertical asymptote. Sometimes they gave us a domain, for example. Suppose I told you the domain is from 0, for example, till a number, any number. Okay, so here you cannot do limit as x tends to 0. You're going to do it from that side. That side, and you have the 0 from here. I want to do it from that side. So I do limit as x tends to 0 plus. It's the same. I replace first of all by 0. You have minus 1 over 0. Okay, but to know if it's 0 minus or 0 plus, take an example of 0 plus. You can put 0.1. So if you replace here by 0.1, you're going to get 0.1 times 0.1 minus 9. 0.1 times 0.9 is a negative number. So that's why I have put negative. So minus over minus is a plus infinity. And if you have it, for example, you have a number here, for example, minus infinity. So here you must do the limit as x tends to 0 minus. First of all, you do 0. as we said, minus 1 over 0. 0 minus less than 0, you can take 0.1. If you replace it here, negative times negative positive, so minus over plus is minus infinity. Let us check for 1. If you want to do limit as x tends to 1, so this is 1 over 0 plus or minus infinity. And if, depending on the interval, if you have like this one, plus a number, for example, infinity, here we do limit as x tends 1 from that side. This is 1. From that side is more than 1. 1 plus, for example, 1.1. So if you do limit as x tends to 1 plus, so 2 minus 1 is 1. 1 plus, take an example, 1.1. 1.1, 1.1 minus 1, all are positive, as you can see, so plus infinity. 1 minus, you can take 0.9. 0.9, 0.9 minus 1 negative, so 1 over 0 minus infinity. So let us find here the asymptote. You have minus 3 and 2. So these are vertical. Let me start by horizontal asymptote. As you can see, degree below is bigger, so you must get 0, y 2x over x squared, which is 2 over x, a number over infinity, so y equal to 0, horizontal asymptote. Now I want to check at minus 3. Minus 3, so here, minus 6 minus 7 over 0, plus or minus infinity. But and limit as x, let me check for minus 3 plus and minus. What is a minus 3? Minus 3 minus smaller than minus 3, right? Less than minus 3. You can take an example of minus 3.1. Minus 3 plus, this is minus 3 minus. Minus 3 plus more than minus 3. More than minus 3, you can take minus 2.1 to minus 2.9. And use it in calculator. So if you want to do minus 3 minus, so up is minus 7, it doesn't change. So here take a calculator and put minus 2.9. Minus 2.9 square, minus 2.9, okay, minus 6. If you do it, you're going to get 0 minus. And if you put minus 3 minus, for example, in a calculator, minus 3.1, here and do it, you're going to get 0 plus. So this is minus infinity, this is infinity. Concerning 2 minus, you can take before, just before 2, 1.9, 2 plus 2.1. So here the same story. If you replace by 2, first of all, a number over 0 plus or minus infinity. If you want to do the limit as x tends to 2 minus, put in a calculator here 1.9. You're going to get 0 minus, so minus infinity, and 2 plus, put 2.1 here, you're going to get, sorry, here 3 over 0 minus, here plus infinity. Is it clear? So depending on the interval, for example, if you have, for example, here interval 2 till infinity, it's better to do limit as x tends to 2 plus only. If you do limit as x tends to 2, it doesn't matter. Okay. So that's it, guys. I'm going to post also another video. It talks about how we graph a rational function. Thank you for listening.